Hello everyone. This is part 2 of a review for unit test number 6, and we left off with some multiplication and division of algebraic fractions, and now we'll finish up with roots and radicals. So to begin with, you might want to create a little chart of the perfect squares. The square root of 4, the square root of 1 is kind of trivial. It's equal to 1 because 1 times 1 is 1. But then the square root of 4 is 2. What you could do is you could just list the integers and then multiply them by themselves to get the radicand that's a perfect square. So 3 times 3 is 9, so the square root of 9 is 3. 4 times 4 is 16, so the square root of 16 is 4. 5 times 5 is 25, so the square root of 25 is 5. And you might want to go up to at least the first 10. 6 times 6 is 6, so the square root of 36 is 6. Whose square root 7, that's 7 times 7 or 49. 8 square root of 64, excuse me, is 8. 9 square root of 81, 9 times 9, 10, square root of 100 is 10, because 10 times 10 is 100, and you might want to go up to 11, and that's probably going to be sufficient, but if you need more, and 11 times 11 is 121, so you could list more if you like. So we'll keep this chart handy. When we're dealing with the square root of a fraction, we could use the property that the square root of a fraction, a over b, is the square root of the numerator, square root of a over the square root of the denominator, so square root of b. So using that concept, we'll write this as the square root of 49 over the square root of 64, and then the square root of 49, if you have to use our little chart here, or you should know the basic ones, but have that handy. Square root of 49 is 7, square root of 64 is 8. Okay, when we're dealing with variables, recall that if we have an even power of a variable, the easiest way to take the square root is just to simply drop the radical and divide the exponent by 2. So the square root of w to the fourth is w squared, because 4 divided by 2 is 2. And that's because if you took w squared, let me just remind you, this is because if you took w squared and you squared it, or multiplied it by itself, remember when we raise a power to a power, we multiply the exponents, and 2 times 2 is 4. This can be extended to more than 2 factors under the radical. Just divide these exponents by 2 if they're both even. So this becomes a squared b to the first, or just simply a squared b. Remember, if the exponent's 1, we do not need to write it. Okay, here, when we have a product like this, I could have actually shown this step as well, that this is really the square root of a to the fourth times the square root of b squared. That's because we have the property that the square root of a product, a times b, is the product of their square roots. So actually here I skipped, going from here to here, I skipped this step. And you could skip that step, or you could show it literally. Let me show it literally again. So here's a product of a coefficient, square root of 16, and then a variable, square root of x to the sixth. And if we take the square root of 16, we get 4. And taking the square root of x to the sixth, divide the exponent by 2 because it's even, so x cubed. So you could show that intermediate step or skip it like I did in the earlier example. This can be extended to more than 2 factors. If you want to show the concept of splitting it up, you'll be taking the square root of 36. You might want to note that the exponents are even, so you go to this step, square root of each one, square root of a to the eighth, square root of b to the 20th, and then take those square roots, or as I said, you could skip this step. Then the square root of 36 is 6. Square root of a to the 8th, it's an even power. Divide the exponent by 2, we get a to the 4th. And b to the 20th, again an even exponent. Divide the exponent by 2, get b to the 10th. When we have the square root of a fraction, we used that property earlier. Square root of a over b is the square root of a divided by the square root of b. So here's that property as we had stated a little bit earlier. So if you want to take the step to show that, square root of y to the 8th over square root of 9, then take each root separately. And 8 is an even exponent, divided by 2, we get y to the 4th, and the square root of 9 is a perfect square, that's just 3. And then if you have a conglomeration of products and quotients in the fraction, just take the square root of everything. Again, I'll show it literally, but you could skip the step. But take the square root of 49, square root of x squared, over square root of 4. And then the square root of 49 is 7. Square root of x squared, divide the exponent by 2, we get x to the 1st, and the square root of 4 is 2. And again, there's no need, that's acceptable, but there's no need for the 1 on the, as the exponent on the x variable. And that's divided by 2. Okay, so final page. Going to simplify. Now we get into a situation where the numbers involved are not perfect squares. And so what we have to do is break it down such that we take out the largest factor that is a perfect square. And as you might recall, there's an easy method for doing this. For example, the square root of 63, that's not a perfect square. Here's my list. So what I'll do is I'll consider breaking this down into the product of two square roots, the first of which is the largest number that is a factor of 63 that is a perfect square. And a nice easy method is to consider just working your way, finding the number amongst the list and working your way up the chart until you find the number that divides evenly into it. So 63, does 25 divide into 63 evenly? No. Does 16? Maybe you might even use a calculator. And for example, you could say 63 divided by 16. No, that doesn't work out to divide evenly. So we'll move up to 9, 63 divided by 9. Yes, that works. Divides evenly to give us 7. So therefore 9 is the factor that is a perfect square, and 7 is what I'll call the leftovers. And then we're going to take the square root of 9, so it comes out of the radical, because it is a perfect square. Square root of 9 is 3, and then under the radical, we leave the square root of 7. Okay, moving to part B, 125, square root of 125. So, using this method, working our way up the chart, you could check them all. 25 works. So we'll break it down into two square roots. 25, and divide the into 5 times the leftover. And getting a little freezing on the video here, so it's going to remedy itself. Okay, here we are. And then the square root of 25 comes out of the radical as 5, and the leftovers square root of 5. Okay, moving to part C, we've got a numerator and denominator. So exercising a property, take the square root of the numerator over the square root of the denominator. Okay, the square root of the denominator is a perfect square, that's 5, but we're going to want to break down the square root of 32. Okay, so again, using the little list here, if we look amongst the list, work our way up. 32 is somewhere between 25 and 36, and 25 does not divide into 32 evenly. So move up. Does 16 divide into 32 evenly? And yes, it does, 2 times. And so put the square root of 16 out in front, and the leftover is a 2. And then take the square root of 16, it comes out of the radical as 4. Leave the square root of 2 over 5. Okay, moving on to part D. Got some variables involved, but now the exponents are odd. So if the exponent is odd, what we want to do is take out all of the even factors, which is really just going to be one less than the exponent. So if I break this down into 2 square roots, the one that is a perfect square is 10 factors, and then I'll have 1 left over. And then the 10 factors that are the perfect square can come out as x to the 5th, because we drop the radical and divide the exponent by 2. So x to the 5th, and then the square root of x to the 1st, or just simply the square root of x is left over. Okay, so when we get a combination of the coefficients with the variable, you could break it down and use the combination of the 2 methods we just discussed. 64 is a perfect square, so I'll put all of that under the first radical. Concerning the variable, y to the 9th, 8 factors, that we take out as many of them that are even. It's always 1 less than the power if it's odd. So 8 of them, and that leaves 1 left over. So then the square root of 64, y to the 8th, here's where I'm going to skip a step. Square root of 64 is 8. Square root of y to the 8th, divide the exponent by 2, we get y to the 4th. And then the square root of y to the 1st is left over. And you could just write that as the square root of y. Okay, moving on. Here we have a situation where the coefficient is not a perfect square. It's 175. So look amongst the list. 25 jumps out. But again, if you have to use the calculator and do the actual divisions. But if I'm going to break this down, I need 25 to come out. And 25 times 5 is 175. I'm sorry, 25 times 9 is 175. No, that's not right. 25 times 7. Let me cross this out. So here's my 2 radicals again. Okay, so 25 and 7. See, I could have used the calculator just to make sure, right? I'm dividing 175 divided by 9, divided by 20 is 7. Yep, so 25 and 7. Okay, and then this has all of the factors, x to the 10th, that are even, so they can go under the first radical with the perfect squares. And then again, I'll skip a step here, just take the square root of 25, which is 5, and the square root of x to the 10th, drop the radical, divide the exponent by 2, we get x to the 5th, and the square root of 7 is left over. Okay, so the final 3 problems. So here's a combination of the concepts. Break it down into 2 radicals again, first of which is the perfect square. Okay, using the method, once again, 54, somewhere between 49 and 64. 49 does not divide into 54 evenly, nor does 36. 25 does not. See, 54 divided by 16. Let me just make sure. Nope, that doesn't work. 54 divided by 9. Maybe you're not real good with your multiplication facts, and you try that. Oops, it's good. 9 times 6 is 54. So I'll put the square root of, put the 9, which is the perfect square, in the first radical. 6 is the leftovers. And now here's a variable with an odd power. So we take out all the even ones, which is 1 less, or 18 of them. and put that under the first radical, and then m to the first under the second radical, the leftovers. And then skipping a step, if you want, you could break this down into the square root of 9 times the square root of m to the 18th, but the square root of 9 is 3, square root of m to the 18th, divide the exponent by 2, get m to the 9th, and the square root of 6m is left over. And again, no need to write the exponent of 1. So finally, a couple situations with fractions. So first step, square root of the numerator over the square root of the denominator. Numerator can be broken down. Square root of 128. So if you use the list, working up the list, 64 is going to be the first one that divides evenly into 128. And again, use the calculator if you need to. So 64 under the first radical, 2 under the second radical, left over. Square root of x to the 10th, you can take care of that now if you want. It's an even power. Divide the exponent by 2. And then the square root of 64 comes out of the radical is 8. Square root of 2 is left over. And I'll recopy the x to the 5th. That's in the denominator. Alright, so the final problem. Now we've got, if you want to break this down initially as the square root of 9, square root of x to the 7th, just take the square root of everything. Square root of y to the 14th. Now the square root of 9 is a perfect square, that's 3. But x to the 7th, its square root, we're going to have to break up into 2 because it's an odd power. So take out all the even ones. There's 6 of them. 1 left over. And for the square root of y to the 14th, it's an even power, so might as well take care of that. Divide the exponent by 2. Drop the radical, we get y to the 7th. And so finally, 3. Square root of x to the 6th, divide the exponent by 2, drop the radical, x cubed, square root of x to the 1st, or just simply square root of x left over, and then recopy our y to the 7th. Alright, so that's the end of the review for unit test number 6, and I wish you the best of luck, and next thing is to prepare for the final exam. So remember, you're allowed a cheat sheet on the final exam, and you may want to include this list of perfect squares to just remind you.